नागा भारत डाटा के एक शास्त्रीय विचार के साथ जिसकी स्थापना की गई, जो था अंतरिक्ष को सबके लिए सुलभ बनाना या ओपनिंग स्पेस फॉर ऑल। सभी इस रॉकेट का काफी समय से भाग या हिस्सा रह चुके हैं, तो अपने अपने अनुभव के बारे में थोड़ा दर्शकों को बताइए।
Right, Akhil. Thank you for asking that. So back then in 2018, when I heard about Skyroot, it was really a mix of excitement and curiosity. For decades, India had looked up to ISRO for every space milestone. India's space sector was open to private participation, creating room for companies like Skyroot to innovate, build, and contribute to the nation's growing space ambitions. Here was a private company which came out of nowhere and it said, "We are going to build an orbital launch vehicle from scratch." On immediate thought, it looked like this is going to be extremely difficult. But if anyone succeeds, it could actually redefine India's entire space ecosystem. It felt bold, it was quite ambitious, and the timing felt quite right. Suyash, what did you make of it?
Yeah, it was pretty mind blowing to say the very least. When we first heard about this, it was extremely exciting. One question that we asked ourselves is we have such a grand vision, but what do we need to do on ground before we can aim for stars? So one thing we realized very early on is every critical piece of technology that we need to fly, we need to test in-house, we need to build in-house. And I got the chance to help build a lot of these technologies. So me with a small team of very ingenious multidisciplinary engineers, we essentially helped build the liquid stages on this vehicle, and working from the ground up, designing and testing the upper stage, the RCS module, sort of taking it from cradle to grave was a once in a lifetime opportunity that we knew that we had to capitalize on. And like they said, the timing was everything because the entire space sector was about to take off.
Yeah, perfectly put, Suresh. I mean, if you look at way back in 2018 when Skyroot was founded, we had just handful of space companies, and now in like close to 2020 we had almost 100, and in 2026 India finally has its first space tech unicorn, and almost close to 350 plus space companies. So I think it's apt to say that Skyroot has pioneered India's private space ecosystem.
Yeah, that's true. And just recently, you were seeing views from the Launch Control Center of Skyroot, and now on your screens is the Mission Control Center, where we have a lot of dignitaries who've joined us. On your screen right now is Pawan and Bharat, and of course Sanjay as well, our mission director. So one of the things that Akhil just mentioned is that it's pioneering the space ecosystem. One thing that comes about is the space market is growing just as rapidly. Space has quietly become part of our daily lives. Every weather forecast that you look at, every map that guides you home, digital payments that you make every day, long distance calls. Each of these have a satellite essentially working in the background, making all of these possible. India's space ecosystem today is worth $8 billion, and we're expecting, the government essentially wants to make it a $40 billion market by 2030. And all of this is a part of global hierarchy. The global market also is inching towards $1.8 trillion by 2035. And it's a market which is growing twice as fast as the global economy itself. And the biggest drivers are here on Earth. We have precision agriculture, farming. There are satellites in space essentially which can capture things which the human eye cannot see. And all of this just presents huge advantages to working for space to make life better on Earth. So, Vedi, I understand you were part of the team that built the first rocket, the Skyroot. So, what was that journey like for the engineering teams from development through to launch?
So yes, now that I think about our first launch, it was really an amazing experience. We had no idea what rocket science is, and it was a really great chance to understand that a rocket is essentially made up of hundreds of small subsystems which are really interconnected. And to make a mission or a vehicle successful, they have to work perfectly in sync. So that whole process of understanding that, oh my God, this is actually rocket science. It was amazing. And Mission Praram in 2022, I'd say it was far more than just a rocket launch. It was the maiden flight of Vikram-1, India's first privately developed rocket. Fittingly, Praram means a beginning in Sanskrit. And for the young engineering teams involved, it was once in a lifetime opportunity to work hands on with cutting edge space technology, build systems from the ground up, make rapid engineering decisions, and take ownership of the critical subsystems. And it was really, really amazing to see that kind of a collaborative effort pay off. The mission was highly successful. It crossed 89 kilometers, achieved all its flying objectives, and I feel like that event, in a true sense, marked the dawn or the praram of India's private space era.
That's really inspiring, Vedahi, and what a perfect way to put it. I mean, and now let's come back to today, and we're getting inputs from the ground station teams that just a couple of hours ago, they have completed a very important step. They have gathered the wind profile data for the launch day, and as we are seeing here, it's slightly cloudy. We had rains last night a little bit. So these launch wind data are captured using Doppler weather radar, and the wind profiles will be then analyzed and will be updated in the program before loading it to the mission computer for the ALS.
Yeah, that's right, Akhil. And this is such a unique step in the launch vehicle program where we collect day of launch winds. Like you mentioned earlier, that it's a bit cloudy today. The whole goal is the strong winds that come about in upper atmosphere or lower atmosphere are capable of nudging the rocket off its course. And so making these adjustments essentially just helps you correct and make sure that you stay on the planned trajectory. So one thing that our viewers are also very curious about is we called our first mission as Mission Praram, that Vedi talked about as well. So the question is, what have we called this mission as? And we're very excited to tell all our viewers that we've called this mission as Mission Agaman. The word Agaman is derived from the Sanskrit word meaning arrival, and it's sort of twofold. The first is it's the arrival of India into a new space era, wherein the private sector takes a huge leap and delivers and caters to the global launch market. But secondly and importantly, it's the arrival of a new launch vehicle, a very capable launch vehicle, to the launch market and help meet some of that global demand. Now, something pretty cool about today's date, and I assure you it's purely coincidental, and it's kind of amazing really, is 46 years ago today, India's first indigenous launch vehicle, SLV, reached space and placed the Rohini RS-1 satellite in orbit and kicked off India's space ambitions. And coincidentally again, 8 years ago today, Skyroot began its journey as well to open space for all. So it's company day today as well.
अवश्य सुयश, इस जानकारी को दर्शकों को प्रदान करने के लिए आपका धन्यवाद। अब हमारे समक्ष हम देख सकते हैं स्काईरूट के प्रक्षेपण नियंत्रण केंद्र के प्रत्यक्ष दृश्य, जहां प्रणोदन, यंत्र विद्युत, दिशा निर्देशन नियमन जिसको हम गाइडेंस नेविगेशन कंट्रोल, ऊष्म वायुगतिक जिसको हम एरोथर्मल, सुरक्षा और यान प्रतिकरण जैसे कि सेफ्टी और सेपरेशन डायनामिक्स डिपार्टमेंट से जुड़े विशेषज्ञ दल यान के प्रत्येक अवस्था पर निगरानी और दृष्टि रखे हुए हैं। ये वही केंद्र है जहां पे प्रक्षेपण की हर महत्वपूर्ण प्रणाली की मुख्य पुष्टि करी जाती है। और अब आइए जानते हैं इस सुबह के प्रमुख नायक विक्रम-1 के बारे में।
Right, Akhil. So VIKRAM-1 is Skyroot's first orbital launch vehicle built specifically to carry small satellites into orbit. It stands 22 meters tall, 1.7 meters in diameter, and its gross liftoff weight is 45,000 kgs. Its first three stages are powered by solid rocket motors. They provide the enormous thrust needed to lift the vehicle up through Earth's atmosphere. The first stage alone develops around 1200 kilonewtons of thrust, roughly 10 times compared to that of a Boeing 737 MAX engine. And that's how the engines get their names. The numbers are the thrust, and they honor Dr. APJ Abdul Kalam. Kalam 1200 for the first stage, then Kalam 250 for the stage 2, and then Kalam 100 for stage 3.
जैसा कि वेदी ने जानकारी प्रदान करी, विक्रम-1 स्काईरूट का प्रथम कक्षीय प्रक्षेपण यान था जो छोटे उपग्रहों को उसकी कक्षा तक स्थित करने के लिए निर्मित किया गया था। इसके पहली 3 अवस्थाएं ठोस प्रणोदन द्वारा संचालित की जाती हैं, तो यान को वायुमंडल के पार ले जाने के लिए अत्यंत आवश्यक प्रबल प्रणोदन बल प्रदान करती है। और अब अंतिम इसका चरण, जिसको हम कक्षा समायोजन खंड, जो कि ऑर्बिट एडजस्टमेंट मॉड्यूल के नाम से भी जाना जाता है, वो द्रव्य प्रणोदन पर आधारित है और उपग्रहों को सटीक कक्षा में पहुंचाने के लिए अत्यंत सूक्ष्म नियंत्रण प्रदान करना इसका कार्य होता है। और ठोस प्रणोदन प्रणालियां जो हमारे स्काईरूट के इंजन हैं, वो उसका नामांकन डॉक्टर एपीजे अब्दुल कलाम के सम्मान में हमने समर्पित किया है। और द्रव्य प्रणोदन प्रणाली के इंजन के सभी नाम, उनका नामांकन डॉक्टर सीवी रमन के सम्मान में हमने समर्पित किया है।
Yeah, that's right, Akhil. You just earlier mentioned the orbital adjustment module. It's one of the liquid stages that we've developed. It has 500 plus components that have to work in unison. It's a very complex stage, and it's powered by liquid propulsion. It differs from the solid propulsion in the sense that it doesn't generate enormous amount of thrust, but it has a certain amount of precision that is only possible with liquid propulsion. So that's where we use the OAM stage for precise adjustments to the trajectory. And that's not the only place where we use liquid propulsion systems. We have an interstage on the vehicle, which sits between stage 2 and stage 3. And its whole job is to provide roll control for the vehicle during its ascent phases.
And all those liquid engines are powered by hyperbaric propellants, right, Suresh?
Yeah, that's right. So we use something known as MMH and N2O4. These are 2 chemicals. They're stored in separate tanks. And the way they work is when you bring them in close proximity to each other, they spontaneously combust. Of course, you need a certain threshold concentration. The whole advantage is then you don't need an ignition system. So you've deleted a failure point, a potential failure point out of the system. So it's kind of unique and useful as well.
That's really interesting to hear, Suresh. And coming back to steering of a rocket engine, for the information of all of our viewers, so this is a rocket model that I'm holding in my hand. So if you suspend it in the air or space, we can say, it has unconstrained 6 degrees of freedom, out of which like 3 are straight line motion, or let us say translational, in which it can move forward, backward, upward, downward, and sideways, and 3 degrees of rotation are rotational, which we call pitch, yaw, and roll. So these are the 3, let us say, mechanisms that are like, we can say, help in steering the rocket engine and the entire vehicle in the sense.
That's right, Akhil. And I believe different parts of the vehicle handle different pieces of that. So on the way up, the solid rocket motors steer in pitch and yaw by swiveling their nozzles. Roll, which is the spin around the rocket's own axis, is handled separately by a small dedicated liquid system during the climb. We have a set of 4 thrusters which fire in pairs to control the roll of the vehicle. And once in space, OM does its own pointing with the help of small thrusters, which Suyash will tell us about.
Yeah, so on the OAM stage, on the periphery of the stage, we have what we call as a Raman mini thruster. So they essentially generate 50 newtons worth of thrust, and they help in attitude keeping, which is essentially making sure that the spacecraft points in the right direction. So that covers the pitch and yaw. What do we do about roll, one might ask? So we have like these small cold gas thrusters. They're placed along the periphery of the stage as well, and they fire in pairs. So with that, they're capable of generating a rolling moment to roll the vehicle. Now, this whole architecture that we talked about, it's something that answers purely to the requirements. It's powerful where it needs to be, and incredibly precise where accuracy matters the most. And this is a philosophy that we've extended beyond propulsion. So all our structures on the rocket are made out of carbon fiber. This is India's first launch vehicle which is made purely out of carbon fiber, and it's 5 times lighter than steel. We also employ advanced propulsion technologies. All our liquid engines are additively manufactured or 3D printed. And all of this, what it contributes to is it reduces the weight, it improves performance, and also increases manufacturing efficiency. The net sum of all these decisions is you have a rocket which is reliable, on demand, and affordable.
That's true, Suyash. So, an update for our viewers. Just a while back, we got a confirmation that the guidance, navigation, and controls team they have successfully completed gyro compassing and the static navigation profiling of the lens package. This is done so that the rocket knows its initial orientation with extremely high accuracy. In the process, the inertial navigation system determines the initial attitude of the vehicle by identifying the true north and the gravity direction with respect to a rotating Earth reference frame. So quite unique it is.
That's true. And it's something very important for you to know where your orientation is before you make that journey to stars. It's sort of like using a compass when you're going out camping. You want to know where north is so that you can chart your journey accordingly.
जी सुयश, और आई थिंक वायुयान में भी इसी सिद्धांत का प्रयोग किया जाता है और वो उसी सिद्धांतों पर निर्भर करती है। तो यदि अब हमको ज्ञात है कि रॉकेट किस दिशा में जा रहा है, हमारा विक्रम-1 प्रक्षेपक यान, आज की इस पूरी यात्रा का लक्ष्य क्या है, वो किस ओर प्रस्थान करेगा?
Today's test flight is attempting a 450 by 450 kilometers circular low Earth orbit or LEO, a region of space widely used for Earth observation, communication, and technology demonstration. But this is a maiden test flight. So what matters most today are the fundamentals. Today's test flight has three prime objectives: executing successful stage 1 ignition and liftoff, clearing the launch tower safely, and then gather as much data as possible from our onboard sensors.
अवश्य उदय, जैसे आपने कहा कि ये एक प्रथम परीक्षण उड़ान है, इसीलिए आज सबसे अधिक महत्वपूर्ण ये है कि अभियान के प्रमुख उद्देश्य को हम जान लें। प्रथम चरण का सफल प्रज्वलन, यान का सुरक्षित उड़ान पथ से निकास और अधिक से अधिक उड़ान अंकों का संकलन। किंतु अंतरिक्ष तक पहुंचना अत्यंत महत्वपूर्ण है, ये हम सब जानते हैं, बट सही कक्षा में उपग्रहों को स्थापित करना एक कठिन कार्य है, राइट?
That's absolutely right, Akhil. It's not sufficient to just simply reach the right altitude. The rocket must inject the payload with the correct velocity, the right flight path, and the precise orientation so that the satellite begins its mission exactly as planned.
Yeah, that's right. Now that we know where Vikram-1 is headed, let's talk a bit about what it's carrying today. So what's on board today's mission?
VIKRAM-1 is carrying two deployable test satellites today. The first one is SCOPE, a test satellite developed in-house by us as a technology demonstrator. Joining SCOPE on today's mission is Solaris, a CubeSat developed by Graha Space, flying again as a technology demonstration payload. And from Germany, T-Cubed is testing two of its own systems, deployment and suppression technologies built to work in orbit.
And there is one more interesting payload that we have is from Cosmos Space, and it's flying soft robotic arms along with the OEM stage that will attempt to capture a piece of simulated debris in orbit. That is a very interesting thing that they're attempting indeed. And it stays mounted to Vikram-1 throughout the entire flight. And if it works, it will be the first of its kind to demonstrate this kind of a experiment. And it's an early step to clearing the space debris in general. That's a great initiative, I think.
Yes, definitely. And there's two more payloads on board, ones that celebrate creativity and India's scientific heritage. The first is Cosmic Blue, a delicate floral diamond artwork from Cosmos Diamonds. The second is quite something else entirely. It's a micro art, an 18-karat gold rocket crafted by Telangana artist Ajay Kumar Matewada, holding three tiny sculptures of Nobel laureate Sir C.V. Raman and visionaries Dr. Vikram Sarabhai and Dr. APJ Abdul Kalam. Each one of them is smaller than a grain of rice, and it's a fitting tribute because all these three names essentially live aboard Vikram-1 itself. The Raman engines, the Vikram-1 vehicle, and the Kalam motors. Now, as we count down, of course, it's worth taking a pause to appreciate where this journey is beginning from. Vikram-1 lifts off from the first launch pad here at Satish Dhawan Space Center at Sri Harikota, more familiarly called as the Shar Range, a place that has witnessed some of the most defining moments in India's space program.
That's correct, Suyesh. This very pad has a proud history and legacy of its own. This is the exact place where Mangalyaan set off for Mars in 2023. And Sriharikota itself has launched India's greatest space journeys, like Chandrayaan to the moon, Aditya L1 to study the sun. And now, our very own Vikram-1 adds its own chapter on its journey to the stars.
That's right, Akhil. Missions like Vikram-1 are helping position India to serve the fast-growing global demand for small satellites, and they reflect a wider momentum as well. Under national initiatives championed by Honorable Prime Minister Narendra Modi ji, Make in India, Atmanirbhar Bharat, Skill India, this country has been building exactly the kind of indigenous innovation, advanced manufacturing, and high technology skill that a vehicle like this is built on, and which is why today's nation is of utmost national importance.
Yeah, and in some of those initiatives that you mentioned, we also have Gati Shakti, which has essentially eased the way we get approvals and get things done. For what could used to take years on end, now is simplified to a matter of minutes just sitting at home.
अवश्य, किंतु उस तीव्र गति और तीव्र प्रगति का बड़ा भाग एक महत्वपूर्ण मोड़ से जुड़ा है, जो कि 2020 में ऐतिहासिक अंतरिक्ष नियमों के परिवर्तन के परिणाम स्वरूप जो इन स्पेस संस्थान की स्थापना हुई थी। और इस संस्थान का कार्य शासन तंत्र और निजी अंतरिक्ष क्षेत्र के मध्य एक समर्थ, सुगम और दूरदर्शी सेतु की स्थापना करना था, जो कि काफी कठिन कार्य है। और स्काईरूट जैसी सभी संस्थानों की ये यात्रा को सशक्त और आधार प्रदान करता है। इसीलिए हम इन स्पेस के प्रति हार्दिक कृतज्ञता व्यक्त करते हैं।
That's right. We have live on our screens views from the launch gallery where hundreds of students, actually thousands of students, have joined us on this historic mission. These are people who are the future of our nation, and we encourage them to join us on this journey with us to the stars, take up projects in future which contribute to the space sector and the national space ecosystems as well. Now that we've explored the significance of today's mission, let's take a closer look at what Vikram-1 is about to do in a few minutes. Of course, Vikram-1 will lift off and ascend vertically from the launch pad before executing a pitch over maneuver, and from there it will gradually transition into what's known as a gravity turn.
That sounds a little counterintuitive, and if the launch vehicle is headed straight to space, then why does the rocket just keep not going straight up?
That's a great question, Akhil. While gaining altitude is important, reaching orbit is all about building horizontal velocity. The gravity turn allows the rocket to efficiently accelerate around the Earth rather than simply away from it, using less propellant while achieving the velocity needed for orbit.
Yeah, and we've just heard callouts from the Mission Control Center that the automatic launch sequence has been activated. It's one of the preliminary starts to the program and a very important point. At this point, the countdown is now fully automated with hundreds of onboard commands executed in precise sequence, leading us to liftoff.
And although the process is entirely automated, I believe the mission teams are closely involved, right? They have to ensure that every system is operating at its nominal health conditions.
And correct, Vijay, if any one of the many critical parameters that we observe in during the entire sequence goes out of its nominal expected bounds, then the rocket smartly aborts the entire sequence and initiates a preloaded set of commands, and that will safeguard the entire vehicle, and then the people stationed at the ground or the engineers can have a closer look, and if the issue can be resolved within the stipulated time, then we'll have the sequence back again and we can go ahead with the launch.
Yeah, that's right. This is something very useful to have wherein engineers can resolve faults and understand if there's something that can be quickly fixed, and then we can continue back on ALS. So I think we were just talking about what the rocket does, and once stage one powers the vehicle for nearly 100 seconds, something important comes, which is max Q.
Right, you're right, Suyash. As the vehicle continues to pitch over and accelerate, it approaches one of the most demanding phases of ascent. Nearly 25 seconds into the flight after the gravity turn is max Q, the moment of maximum dynamic pressure. This is when the rocket experiences the greatest aerodynamic loads, a true test of its structural strength and engineering precision.
Yeah. So now we're at T minus 9 minutes and we're entering another crucial phase of the launch countdown. The launch team is now carrying out a final series of vehicle health checks and making sure that Vikram-1 is fully prepared for flight.
Yeah, as we can see on our screens, one of the most key milestones at this stage has been completed. That is the transition from the external ground power to the rocket's onboard batteries. Up till now, the vehicle has relied on its own ground support systems, but from this point forward, every stage must successfully power itself. And engineers are closely watching the battery performance and electrical health to ensure that this transition is very smooth and every system remains entirely stable.
Right, Akhil. With the power transition complete, attention would shift to the rocket steering system. Engineers will now be verifying that the thrust vector control, or the actuators as we call it, the mechanisms which steer the rocket by precisely directing thrust through powered flight.
Yeah, and you mentioned these actuators. Essentially, all of our solid rocket motors are equipped with what is known as a flex nozzle control. Sounds like a bit complicated term, but it's quite simple. It's just the nozzle is capable of swinging in two planes, and the way we achieve this motion is by using electromechanical actuators. So you might imagine that this is something very important that we should check. So what engineers do is they perform something known as a null check. Essentially, they currently try to hold the nozzle in a neutral position. And then once that is confirmed, they provide small commands to the nozzle to deflect it. And if the response is deemed to be normal and the position is correct, we can be rest assured that the rocket will obey every command that is issued to it by the guidance computer. All right, live on your screens right now is the Vikram-1 rocket. And for a long time now, we've been looking at these views, and the biggest thing that comes up to our mind is, wow, that's a marvelous piece of engineering. And it's actually rocket science, right? There's a nearly 1,000 systems that need to work in perfect synchrony just to make liftoff happen, and that's 2/3 of all systems on rocket. So 2/3 of all system on the rocket need to work perfectly to make liftoff happen. And while it's so easy to look at the rocket and be amazed by its beauty, we would like to take a small pause and focus on the fact that behind every bolt, every wire, every line of code that is on the rocket today, it's been built by people. People whose passion, perseverance, and dedication have made this moment possible. Of course, a launch vehicle is never built overnight, and it's the result of countless people obsessing over one thing to make it perfect.
Exactly, Suyash. We often celebrate rocket launches, but rarely appreciate the engineering complexity behind that. And the most primary guiding principles in Skyroot is our people are our thrust. So it's not just the rocket alone that pulls the company up. It's just the people that pushing forward, pushing the entire technology forward, and all the hard work. So Vaidehi, after working on an orbital launch vehicle yourself throughout these years, what has been your biggest realizations in designing the rocket?
One of the most important realizations which I've had is, as Suyash also mentioned earlier, rocket consists of almost around 1,000 independent subsystems, and they are deeply interconnected. A seemingly small error in one discipline can propagate through multiple subsystems and ultimately jeopardize the entire mission. Rockets operate with extremely tight margins, so local design inaccuracies rarely remain local. This interconnectedness is precisely what makes launch vehicle design both extraordinarily challenging and intellectually rewarding. Each deviation might appear acceptable individually, but they can also collectively they can all consume all the design margins available.
Yeah, so we have a planned hold at this point. As you might see on your screens, the timer is paused at 5 minutes. Um, so we will be checking with the internal teams, and we'll get back to you with the countdown shortly. All right. While we wait for this countdown to resolve, there's so many cool facts about space, and something really fascinating that always catches me is when Vikram-1 races through the atmosphere, it's not just fighting gravity, it's also battling extreme aerodynamic heating. And one thing that's always curious is why is the rocket heating up while it's going up in the atmosphere?
Right. So as we are accelerating into the dense atmospheres of Earth with velocities almost three times, four times that of sound, the air in front of the vehicle rapidly gets compressed, and just outside the vehicle surface will have extremely high temperatures, which then get converted into the vehicle surface. So, just a simple question: do you guys know like what is the heat flux which we face standing on the Earth's surface due to the Earth's radiation?
I think 1000 watt per meter square, kind of. Am I right?
That's right. That is 1000 watt per a meter square. It's around zero point 0.1 watt per centimeter square. When Vikram-1 ascends into the Earth's atmosphere, its nose tip can face around 15 watt per centimeter squares of heat flux.
That's pretty large. I mean, as compared to humans. Okay. Yeah.
That's right, that's right. And we really need to design a thermal protection system to keep the structural design under the set constraints. If we don't design any thermal protection system, the vertical surface might end up going to 1500 degrees Celsius. And
Control to all stations. There is a hold observed at T-5 minutes. All stations are requested to be on standby mode.
We have received confirmation that this is a planned hold and we've been advised to stay on standby. We will communicate regular updates to you, so please stay tuned with us. All right. Another fun fact while we wait for this poll to resolve um, is we always take pride in naming our hardwares, and most of them have been in honor of some exceptional minds. So, Akhil, why don't you tell us about some of our naming conventions?
Yeah, I mean, if you can see in the rocket itself, all our rockets and the launch vehicles are named in the honor of Dr. Vikram Sarabhai, the very like father of Indian space program we call him. And all our solid rocket motors, their names are dedicated to Dr. APJ Abdul Kalam, our very own missile man. And all our cryogenic engines, we have dedicated the names to Dr. Satish Dhawan, which we are like the center we have also Satish Dhawan Space Center dedicated to him. And then we have our hypergolic engines, Raman, and then we have dedicated that name to Nobel laureate Dr. C.V. Raman, and our mission computer after the renowned mathematician Srinivas Ramanujan.
So yeah, I think we're gonna keep up this idea of naming our hardwares after scientists.
Until we run out of scientists.
Yeah, so I think
Not the hardware.
we need the young budding uh, viewers who've joined us in the launch gallery to become scientists themselves and famed scientists who take India to great heights, so that we may have names.
Yes, right now maybe. Coming to one more interesting fact, I think a lot of people they don't know this. Like, if you look at a launch vehicle, it seems pretty rigid at first. But the interesting fact is when the entire rocket, when in flight, it experiences combined effect of aerodynamic loads, engine thrust, wind gust, and due to different steering maneuvers, the teams or the designers deliberately give some flexure or like they make rockets slightly less rigid so that it can actually bend along its length throughout the flight. This is intentional, that designing an absolutely rigid rocket would make it significantly heavier and less efficient. And it also creates complex engineering challenge. As the structure bends, the onboard sensors can detect these motions, so the guidance and control system must distinguish the rocket's actual altitude and structural flexing to avoid unnecessary control corrections. And engineers carefully predict these bending modes and their natural frequencies through the structural dynamics and aeroelastic analysis, ensuring the vehicle remains stable even as it flexes its way through one of the most demanding phase. And this flexure could go up close to 10, 10 centimeters, I think. Yeah, close to 10 centimeters. That's pretty huge.
That's right, Akhil. Something for the kids who might be, looking at this live stream. So rockets don't just fly; they keep falling around Earth. It might be difficult to imagine this, but people are often imagine astronauts escaping Earth's gravity. The truth is, gravity never lets go. Even the International Space Station is constantly falling towards the Earth, but it's moving sideways at so high speed that it keeps missing the ground. And that's what we call as orbit.
Yeah, that's wonderfully put.
Orbit is a state of perpetual freefall.
Yeah,
Wow.
that's right. And you spoke about how astronauts on the International Space Stations are also constantly falling towards Earth. And with us today in the Mission Control Center is our very own astronaut, Shubhanshu Shukla. He's been following Skyroot's journey from a very close distance. He's part of our family as well, and he's here to cheer us on. So we thank him for his presence.
One more interesting fact for our viewers that rockets get lighter every second. Unlike an airplane, a rocket becomes lighter every second because it continuously burns and throws away propellant. Because in aircrafts we have air breathing engines. So the oxidizer itself is the air that the turbofan sucks in. But when you have a rocket, when you have a rocket, you cannot have yeah. So when we are dealing with rockets, there is no air outside air can enter and can be utilized for propulsion. So we have to carry our own bottles of oxidizers and fuel. And once the rocket is ignited and it's on its way through the entire flight, the propellant is expelled. And when the stage gets burned out, it's also thrown away or jettisoned. So that is why rocket keeps accelerating, because there is less and less mass to push.
That's right, Akhil. A rocket may weigh hundreds of tons on the launch pad. Consider our Vikram-1, it weighs around 45,000 kgs on the launch pad, but nearly 90% of that weight is just propellant.
That's really amazing. That structural mass is so less.
The views on your screen are from the launch gallery at Sriharikota, and we have thousands of students who've joined us from all over the nation, and they're eagerly waiting the launch of India's first privately built orbital launch vehicle, Vikram-1. And of course, like I mentioned earlier, it's a test flight, and we'll be doing a few of these before we move into routine commercial operations. We are in a state of hold for now. For the viewers who just joined us, we have successfully initiated the automatic launch sequence at T minus 11 minutes, and a lot of the key events um, that went into this have been executed. We have a hold right now at T minus 5 minutes, and just to recap, we had the switchover to internal power, wherein the vehicle is now powering itself. All of the null checks on our actuators have been completed. So essentially, the vehicle's steering systems are in great health. And we're at a planned hold. One quick look at the rocket as well, standing on the launch pad. All right, we're getting updates from the mission control teams. The hold that you observe on your screens was due to a hold raised by the navigation team.
Vehicle directed to launch
Yeah.
control. Please do the needful pre-exercises to reinitiate ALS. Your readiness.
And we've gotten confirmation that we will be starting ALS shortly, so please stay tuned. So we had a planned hold, and we've just heard from the mission teams below that we are ready to restart the automatic launch sequence shortly. And just to recap once again, Vikram-1 is on the launch pad. It's ready and eagerly awaiting its first test flight. We've had the initiation of the automatic launch sequence, and through that we've completed the internal power switchover, which means the vehicle is now powering itself using its own batteries. We've also had the null checks been completed, and we're now waiting for the next window to come about for the ALS to restart.
So now that we know that the ALS is on hold and soon we'll be back with a new time and the restart of ALS, let's talk about the entire journey of Vikram-1, the mission sequence. Now we know that for first 100 seconds of the flight, the stage 1 will power the rocket to the denser layers of the atmosphere, and exactly at an altitude of 53 kilometers at 103 seconds, the stage 1 burnout will happen and stage separation will initiate. And after that, the stage 2 will ignite and it will power the rocket through the thinner layers of the atmosphere while keeping the same level of acceleration. That is the point. And later on in the stage two, during the stage two burn duration, later half, you have payload fairing and it separates. And this is the first time when the payload or the satellite is exposed to the atmosphere or to the space, thinner, the higher layers of atmosphere, which is exactly nearly close to space. Having protected the satellite throughout the ascent, that the fairing's job is done.
Yeah, that's right, Akhil. And you mentioned that the PLF or the payload pairing is the portion that essentially protects the satellite from the difficulties of the environment that the rocket goes through. Question then becomes, how do we separate all our stages, right? So we use something which is very unique. We're very proud of that. In-house to Skyroot, we have the separation teams which develop a pneumatic ultra-low shock mechanism. And the whole goal of this mechanism is it relays very little shock to the payload itself. So the payloads usually carry very sensitive electronics and instruments. So if you have a shock event come about, it may damage some of the sensitive instruments. So that's why we specifically made it a point to develop this pneumatic ultra-low shock separation mechanism.
Like for the knowledge of our viewers, I would also like to reiterate most typical rockets they use gyrocords, which use explosive charge to shear out the bolts and separate or jettison the entire stage, which could be catastrophic for some sensitive payloads. That is very costly and could be like you might lose some data in the satellite and affect its workability.
Control here, go ahead.
Definitely.
Still external hold board is some.
Right.
Noted.
Now, even after the payload fairing has separated, the job isn't done yet, right? The climb is still going on. Stage 3 steps in and it generates quite a large amount of thrust to essentially power the vehicle into orbit. It keeps pushing it to near orbital velocities. And then comes something different, like we talked about earlier. We have the orbital adjustment module that kicks in. And this is the stage that I got to work on very closely. Like I mentioned earlier, it was a team of very ingenious, multidisciplinary members. We had teams from systems, propulsion, dynamics, quality, safety, reliability, CFD, design. I mean, you cannot count these fields on the fingers of your hand. And they all had to work in unison to build this stage. And then once it starts working, it will precisely place all of these satellites into its intended orbit. And you might feel like all of this is happening. There's so many things happening, right? But it's just 16 minutes. That's all it takes.
So fast, but it seems really long. Like it took us like 1 hour from the entire bus stand to reach Sriharikota. But as Suyashu pointed out, so it's such a, we can say the entire rocket engineering, the complexity, looking at the complexity, it's like an entire opera house. You have to be like a soprano. You have to be so perfect. Every system, every individual and every component should be in tune to engage all the systems at the right moment so that we can have even a small ignition. And now we have a VIKRAM-1, which has close to 1,000 subsystems, and almost 2/3 of it will be utilized just even at liftoff. That's really fascinating.
So we've gotten confirmation, and you might see it on your screen shortly as well. The countdown has restarted. We are resetting to T-minus 20 minutes, and we are at T-minus 19 minutes for the information of all our viewers.
Other ground stations about the new T0. Please
Control timing in Excel hold board.
Copied new PGM files shell.
To control timing in Excel.
Roger.
LCC to all. S2 and S3 HMSEs event number 97 completed.
Roger. Control to LCC, MCC and RSO. Please note timing confirmed external hold mode.
to all station. New T0 is 12:05:30. All right, we are hearing from the mission control that the new T0 time or the liftoff time for mission Agman is reset to 12:05 p.m. So stay tuned. We'll be with you, and we'll give you some more space trivia. We have a lot of those, and we'll also take you through the journey of the rocket as well. Many of the times, one of the questions that comes is why space? It's so hard. Uh, Getting to space is hard enough. Getting to space on the first try is even harder. So if it's so hard, why do it at all? What does it hold of such huge importance that we want to strive for making to the stars?
I mean, if you think about it, all the activities that happen on Earth, they are connected in some or the other way to space. Space has quietly become a part of our daily life. Every weather forecast, every map that guides us home, every digital payment and long distance call leans on us. It all leans on a satellite somewhere overhead.
And I mean, it's like the human curiosity that takes you really farther. And like humans, we actually like complex things, and we just like it's not just enough to stay on one planet. And so that's why the man decided to take a decision to set off to some higher horizons. And it was still, after 1890 years, the complexity still remains so high in space travel.
Yeah, and one question that comes about is how do you make all of that happen?
The new launch time
So,
12:05:30.
right, we've just gotten call out and confirmation that the new T0 is 12:05 p.m. Just as a reiteration to all our viewers. So we were talking about what it takes to make all of these happen, and of course, we would like to thank ISRO for all their support, from opening the doors to the Satish Dhawan Space Center, the historic first launch pad, issuing us guidance and helping us with all the nitty-gritty details. They've worked with us day and night on this. They've treated this vehicle as though it were their own, and they're so committed to making sure that mission Agman reaches its intended orbit, that they've essentially become a part and parcel of the Skyroot family.
They treated the vehicle as their own, as you correctly said, Suyash. Like they have been involved with us throughout the entire campaign. And along with ISRO, we would also like to make a positive thank in space. And they have acted as a bridge between the government organization, facilitating all the review meetings, everything, and allowing us access to SHAR, all the policies, all the reforms. So thank you in space for all the efforts, and thank you for rooting for Skyroot.
Yeah, one interesting thing, and this is a personal experience as well. We did Mission Prarambh in November 2022, and believe it or not, the headquarters of InSpace were inaugurated in June 2022.
Just 6 months from our first launch.
So you might have to imagine that it's just 6 months, and they've had to imagine and they have to write and draft all the policies that are required. They have to make sure that they know how the mission is going to be, regulated. What do we need to do? Essentially, handhold the space sector, the private space sector.
It was very seamless, indeed, very seamless. The way they took all of it.
Yeah, very true. It definitely is not an easy job, and they've excelled at it. Same goes with ISRO. We've had, cases where they've been chasing after us.
Yeah. I remember those days.
Yeah, and it's quite, empowering to know that the government is playing such a huge role in helping make this happen. We talk about Atmanirbhar Bharat, we talk about Viksit Bharat 2047, and all of these technologies, what the private sector is trying to build today, is essentially contributing to that goal. Um, if we want to be the world leaders, we need to start now.
Exactly, Suyash. Like I was fortunate enough to visit the LPSC test facility when I was with the Raman 1 test campaign. It was a very great experience. I mean, and the coordination with ISRO teams and the way they facilitated the entire test campaign and the data analysis and post test the data came like really fast and like they were after us and they were very patient with us. So yeah, that was a really great experience for the young engineer like me.
Yeah, and that sort of reminds me to the stage test that we did just a couple of months ago. I think nearly 9 months ago.
Yeah, around I think October.
Yeah, October, I think. And so that was the test of the orbital adjustment module. It was a all-inclusive test. We had the entire stage. We had all the engines, the thrusters. We had the avionics. We had something quite interesting, melodic as well. We played Sare Jahan Se Acha using the Raman Mini thrusters on the stage, which was something very unique, very captivating to the young minds. Many people did not think that you could play music out of the screeching sounds of 50 Newton Raman Mini thrusters.
Again, an opera, I told you, right?
Yeah, definitely.
Minutes 11 minutes.
Automated launch sequence initiated.
Roger.
All right, we're at T minus 11 minutes again, T minus 30, 10 minus 10:30, sorry. And the automatic launch sequence has begun. We are in the pre-checks phase at the moment, where all the teams are essentially checking the health of the vehicle once again, making sure that all systems are operational and go for launch.
Before that, we had one confirmation that all the ground stations supporting today's mission, they have completed their readiness checks. As the vehicle travels downrange, telemetry will seamlessly transition between multiple ground stations, from Shah to Port Blair, then Bogor in Indonesia, and then finally Yatharaga in Australia. This network ensures continuous communication with the launch vehicle, with all mission data relayed back to mission control in real time.
That's right. And just to recap to all our viewers, some of the callouts that have happened till now. We first had the acquisition of day of launch winds, which is we acquire using a Doppler weather radar the winds prevalent. And as Akhil mentioned earlier, it's slightly a cloudy day today for launch, but come rain or sunshine, we are always ready to launch.
Rain can't stop us, I think.
Yeah, and the next thing that we managed to do is, of course, the guidance teams have completed the static navigation profile as well as the gyro compassing of the lens package. So this is kind of the sensor which tells the attitude of the vehicle, essentially tells you how you're oriented with respect to Earth. And it's something very important that the vehicle has to do, needs to know where north is and where the direction of gravity is. Post that, like Vaidehi just confirmed, we've had all the ground stations. We have 4 ground stations supporting us today. Sharp, which is where we are coming to you live from, and then we have Port Blair, following which we have Bogor in Indonesia, and finally the Yatharga ground station in Australia. So all of these ground stations essentially capture telemetry, which is the data from the vehicle,
minus 8 minutes.
and relay it instantaneously to us.
Yeah, Sriyash, you were mentioning about how we also see the wind profiles. The wind profiles are also checked. Just a while back, they were checked. And as I can see on the MCC, this wind profile or this data of the winds is also going to be uploaded into the mission computer in the sequence that is coming up. And also, one of the key milestones which have been completed is the transition from external ground power to the rocket's onboard batteries. The vehicle has relied on ground support systems till now, but from this point forward, every stage must successfully power itself. So, engineers, I believe, are watching the battery performances and electric health right now to ensure that the transition is smooth and every system is remaining stable as of now.
And for this stage sequence also, we have completed all the null checks for all the stage nozzles, and the FNCs are working. And we are also happy that Dr. Jitendra Singh, Honorable Minister of Space, is joining us live on video call, and he's rooting for Team Skyroot.
We are at T-minus 6 minutes and counting. For the viewers who've just joined us recently, on your screens right now is the Skyroot Launch Control Center situated at Shah. We have many engineers looking at the vitals of the vehicle. This includes different teams, starting from avionics, guidance, navigation, control, liquid propulsion, solid propulsion, safety, reliability, quality, and of course our IT teams as well. One of the things that has also been completed just now is the uploading of the mission computer init files. That's a funny name of sorts, but it essentially means initialization files. These are essentially files that contain all the requisite parameters to tell the vehicle what it needs to do in the early ascent of flight. And it adjusts for the day of launch wind profiles that we talked about. It also has the gyro compassing details within it.
And now we have confirmation that mission computer mode has been successfully changed to flight mode, and we are really jubilant, and everybody is really happy that this stage has been successfully transitioned, and now we'll move towards the next check, that is HMSA disarm.
As we enter the final few minutes of countdown, another key safety milestone is underway. The head mount safe arm mechanism will be activated in a while, and till now it was ensured that the ignition chain has remained safely isolated.
That's right, Vedi. For the viewers who are very curious for this, the head mount safe arm mechanism, which we refer to as HMS, is a safety device which is well mounted at the head of our solid rocket motors. And the whole job of this device is to safely isolate the pyrotechnics from the rest of the solid grain. And the reason why we do that is for safety, to prevent any accidental ignition from, let's say, lightning strikes. We do have a cloudy day today, and of course, we have lightning suppression systems. We have 4 lightning towers on the first launch pad. But there can also be some form of electrical runaway. There can also be static discharge. So to safeguard all these devices from electrical discharges, we have a mechanical separation between the pyro devices and the solid rocket motor.
Right, so yes. So till now, the ignition system
T
was
minus 3
in
minutes.
a protective, non-firing state, but now it's going to move on to a state wherein once the mission computer gives the ignite command, it can initiate a pyrotechnic chain of events.
That's right. And we're at T minus 3 minutes, and we have confirmation that the stage 1 head mount safe arm mechanism, or the stage 1 HMSA, has been successfully armed.
This basically means that our motor is now ready to ignite.
That's really great to hear. Along with this HMSA safety mechanism, we have one more layer of safety, which we call the FTS or the CDS, Command District System or the Flight Termination System. This is utilized when if the vehicle during its flight mode tries to or like deviates from its intended flight trajectory, then the range safety officer can take a call to destruct the vehicle to safeguard the resources around it.
T minus 2 minutes.
That's right. As is with the case with any launch vehicle, we always prioritize safety, and with that in mind, we have all of these systems set up on the vehicle. We are now entering to condition the liquid stages on VIKRAM-1. So the orbital adjustment module is now conditioning itself, preparing for liftoff. So we are nearly at T minus 1 minute,
All stations.
and
Remember for the time.
we will leave you
T minus
with
1 minute.
views of VIKRAM-1 and join you shortly at liftoff.
Minus 55 seconds. Minus 50 seconds. Minus 45 seconds. Minus 40 seconds. Minus 35 seconds. Minus 30 seconds.
Real-time programs activated.
Minus 25 seconds. Minus 20 seconds.
Minus 20 seconds is the call out now.
Minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
And we have liftoff of VIKRAM-1, India's first private orbital launch vehicle, and we have great views coming from the tracking cameras. And isn't this
विक्रम-1 ने अपनी उड़ान भरी है। प्रथम चरण का प्रज्वलन प्रारंभ हो गया और विक्रम-1 ने प्रक्षेपण पथ को लांघकर आकाश को भेदने का निर्णय ले लिया है एक ब्रह्मास्त्र की तरह।
That's very true, Sriyash Mathur. And also at the sheer power that stage 1 is producing. With this, we have two of our major prime mission objectives completed, which was successful ignition and safe tower clearance.
That's right, and we're coming up on max Q now, which is the period of maximum aerodynamic pressure, where the vehicle faces its largest aerodynamic loads as it flies through this zone at Mach 1.5 at an altitude of nearly 9 kilometers.
विक्रम-1 ने सफलतापूर्वक मैक्स क्षेत्र पार कर लिया है और दल काफी उत्साहित है इस समय और विक्रम-1 प्रथम चरण के आगे बढ़ रहा है और हमें श्रीहरिकोटा व पोर्ट ब्लेयर पृथ्वी स्टेशन से मजबूत दूर संकेत मिल रहे हैं। बहुत ही अच्छा खबर है।
That's right. We are at a downrange distance of 22 kilometers with an altitude of 34 kilometers. And on your screens right now are excellent onboard camera views from the vehicle.
And we can also see quite nominal chamber pressure values on the MCC screen.
The vehicle is currently at an altitude of 50 kilometers.
और यहाँ पे प्रथम चरण का प्रतिकरण हो चुका है और द्वितीय चरण का प्रज्वलन भी प्रारंभ हो चुका है.
This is a major achievement for the nation with the vehicle successfully separating stage 1 and the ignition of stage 2 as well.
द्वितीय चरण अपना सफलतापूर्वक कार्य पूरा कर रहा है और प्रथम चरण का दहन अथवा प्रतिकरण समाप्त हो चुका है.
The vehicle is at an altitude of 89 kilometers, traveling at 2.6 kilometers per second. Of course, our target velocity for today is 7.6. We've just heard call out that the S2 performance or the stage 2 performance is nominal.
ये एक ऐतिहासिक क्षण है पूरे भारत और निजी अंतरिक्ष यात्रा का.
This vehicle has crossed 100 kilometers of altitude, which is the notion of edge of space, and we have reached space, guys.
VIKRAM-1 is in space.
हमारा यान अंतरिक्ष तक पहुंच चुका है.
And we've had callouts of separation of the payload pairing. We have successful payload pairing separation.
It's nearly at an altitude of 120 kilometers, and the protective fairing is no longer and has been cleanly separated from the water.
द्वितीय चरण का भी प्रतिकरण संपन्न हो चुका है और तृतीय चरण का प्रज्वलन भी प्रारंभ हो चुका है.
That's right, Akhil. We've had successful ignition of stage 3. The vehicle is currently at 157 kilometers above the Earth's surface. It is 355 kilometers downrange, traveling at nearly 4 kilometers per second. Now, the LMP will switch over from Shah to Port Blair and Pagda to Bogo.
अब यान अपनी अंतरिक्ष यात्रा पर निकल चुका है. द्वितीय चरण का प्रज्वलन चालू है और उसकी प्रतिक्रिया नियमित रूप से चल रही है.
And as you can see on your screens, we have near exact following of the intended trajectory. The two dotted lines on your screen essentially indicate the current performance of the vehicle, and it closely matches with prediction. This is on your screen on board from stage 3. What you see is the rocket plume and the nozzle and Earth, our home.
What a beautiful view. क्या सुंदर दृश्य है हमारी पृथ्वी का. और तृतीय चरण का परफॉर्मेंस अब नॉर्मल है या कि सामान्य रूप से तृतीय चरण का संचालन प्रारंभ हो चुका है और चल रहा है.
That's right. We've had call out that the stage 3 performance is nominal.
Plus 5 minutes.
So stage 3 has a propellant loading of 2.5 tons, and we've had burnout of the stage 3 motor as planned at 5 minutes. Yes, we've gotten confirmation that S3 has burnt out, and now we're entering a planned coast period, something that lasts for 140 seconds, in which it's called as combined coast. Right, so we've got call out that the combined coast is nominal. This will last for roughly 140 seconds, where stage 3 is not producing thrust, but it's connected to the vehicle and it's going to coast as a single body. All of this is done to manage the altitude of the vehicle and also control where the stage will re-enter the Earth's atmosphere before splashing in international waters in a safe and planned manner. And jubilant views from the Launch Control Center, where the teams are extremely elated and excited.
और मिशन नियंत्रण केंद्र और लॉन्च नियंत्रण केंद्र से आपको दृश्य दिखाई दे रहे हैं. सभी यान परीक्षण दल अत्यंत ही प्रसन्न हैं और यहाँ पर जो प्रसंग है वो एक उत्सव का प्रसंग बन चुका है. एक ऐतिहासिक क्षण भारत के निजी अंतरिक्ष उड़ान का. विक्रम-1 यान अब अंतरिक्ष में स्थापित हो चुका है. तृतीय चरण अब अपने कोस्ट फेज पे है और ये कोस्ट फेज अभी आप कैमरा व्यूज देख सकते हैं अपने प्रक्षेपण पर्दों या मोबाइल स्क्रीन्स पर, जहां पे आपको धरती का एक सुंदर दृश्य दिखाई दे रहा है.
As we can see on our screens right now, it's really amazing to see that Vikram-1 as of now is going along its intended trajectory exactly as expected. Our plots are really overlapping. The predicted velocities and the current flight velocities are exactly matching. And aren't you guys speechless right now?
I mean, yeah, मेरे पास शब्द ही नहीं है, मतलब ये मैं निशब्द हो चुका हूँ.
That's right. We are approaching another point wherein S3 will separate.
और तृतीय चरण का प्रतिकरण भी हो चुका है.
And you see wonderful views of S3 separating. And now we have combined coasting has ended, and stage 4 will now coast on its own for the next 130 seconds. So stage 4 will now fly on its own, essentially, and
The control thrusters on the OM will be continuously turning on and off to maintain the attitude of the stage, making sure that it is pointing the right way. This also ensures that the antennas can maintain connection with the ground station and the satellite can be pointing in the right direction.
that's right. So one unique thing that has been done during separation is we've essentially fired all 4 of our Raman Mini thrusters to sort of push stage 4 away from stage 3, and that just sort of guarantees that there is some minimum separation between the two.
अब आने वाला जो चरण है वो द्रव्य प्रणोदन पर आधारित होगा, जिसको हम कक्षा स्थापन या समायोजन खंड ऑर्बिट एडजस्टमेंट मॉड्यूल के नाम से भी जानते हैं, जिसमें द्रव्य प्रणोदन की अवस्थाओं से संचालन होगा, जो मोनोमिथाइल हाइड्रोजीन और डाइनाइट्रोजन टाइट्राऑक्साइड पे आधारित है. उसके साथ यान के ध्रुणी नियंत्रण के लिए, जिसे कंट्रोल थ्रस्टर्स कहते हैं हम लोग, रामन मिली 50 न्यूटन, वो भी मोनोमिथाइल हाइड्रोजीन और डाइनाइट्रोजन टेट्रा ऑक्साइड पर ही आधारित है. उसके अंतर्गत हमारे पास छोटे कोल्ड गैस थ्रस्टर्स जो कि नाइट्रोजन गैस पर आधारित हैं, वो भी कक्षा समायोजन खंड पे स्थित है.
And we've heard call out that S4 or stage 4 has ignited successfully.
और चतुर्थ और अंतिम चरण का भी प्रज्वलन हो चुका है.
The liquid engine has come alive over 400 kilometers above the Earth, beginning a burn that will last for more than 6 minutes. During this phase, the vehicle will steadily accelerate from about 6.68 kilometers per second to nearly 7.64 kilometers per second, delivering the precise velocity needed to achieve its planned 450 by 450 kilometers circular low Earth orbit at a 60-degree inclination.
और यहाँ पे आप देख सकते हैं कि प्रक्षेपण नियंत्रण केंद्र में उत्साह का एक प्रसंग आ चुका है, और आपके ऑन बोर्ड प्रक्षेपक पर्दों पर हम देख सकते हैं कि पेलोड्स या जो उपग्रह हैं उनका एक चित्र. यहाँ पे सारे उपग्रह अपने स्थान पर स्थित हैं.
That's right, Akhil. We've also had seamless transition from the Bogor to the Bogor station, and now we are receiving strong telemetry from the Bogor as well as the Yatharga stations in Indonesia and Australia, respectively. The current altitude of the vehicle is 426 kilometers. Our target is near 450. We're traveling at 6.5 kilometers per second. And like we said earlier, OAM is essentially going to fire its Raman 2 engine for a cumulative burn time of nearly 6+ minutes. So this is the longest burning. It's the smallest in thrust, but it burns for the longest period of time. And it's all given to us by Raman 2, our main engine for this mission.
So yes, it must be a really amazing feeling, right? I mean, you and your team worked on this engine to get it going, and it is finally taking us to space.
Yeah, it's a feeling that's really hard to describe. Me and my team, we worked on this engine to get it going, and it's finally taking us to space. This engine wasn't an easy design. Raman 2 generates 1500 newtons of thrust, and it employs three different types of cooling. As if one wasn't enough, we had to put in three. So we have regenerative cooling, then we have radiative cooling, and we have film cooling. And all three of these need to work seamlessly in sync to deliver this phenomenal outcome. So I'm kind of glued to the screens right now. You might just see me peeking over to try to see what the chamber pressure, what the thrust, and what the temperatures are like. But I think I might have to hold for a bit and look at that data in a little while. So while I was talking about Raman 2 and how difficult it was to essentially design an engine this small, um, like I said, it's a relatively small engine, and the cooling design on this was exceptionally difficult to manage because the engine has to generate a lot of heat during combustion, and the temperatures can reach up to 2700 degrees. That's pretty hard for any metal or any material to sustain. In fact, many metals would just vaporize into thin air at those temperatures. So to make all of this work, we employ something known as regenerative cooling. Yeah, and we've gotten call out that the S4 performance is nominal. And so I was mentioning about the regenerative cooling, and the best way to understand this type of cooling is to imagine multiple tubes joined side by side and then arranged into a circular fashion to form the thrust chamber. And these tubes, they need to be very, very thin to exchange heat effectively, which means that manufacturing is usually a challenge. And even after the temperatures would still be too high for normal metals to handle. And for this exact purpose, we employ something known as film cooling. And even though it sounds like a fancy name, it just involves injecting fine jets of fuel along the walls of the chamber to effectively add a barrier of colder gas between the combustion chamber and the metal walls. And essentially, one question I get asked very often is, if it's like that, then why is it called regenerative cooling, right? The whole thought process is the tiny tubes that we just talked about. Those tubes, like 15 minutes.
और यहाँ पर हमको मिशन नियंत्रण केंद्र से संकेत मिल रहे हैं कि चतुर्थकरण चरण का भी परफॉर्मेंस सामान्य है और अभी यान 450 किलोमीटर की ऊंचाई तक पहुंच चुका है जो कि उसका निर्धारित कक्षा है और कोस्ट फेज प्रारंभ है
जी हाँ, and it's traveling at 7.3 kilometers per second at an altitude of 453 kilometers right now. So coming back to the regenerative cooling point of things, the tiny tubes around the thrust chamber of the engine essentially have fuel pumped through it. And we've got confirmation that we have cutoff of the Raman 2 engine, which means separation of the Solaris satellite and the space satellite. VIKRAM-1 successfully. And we have reached space on our first attempt successfully.
इतिहास में पहली बार एक यान ने अपने प्रथम परीक्षण उड़ान में ही उपग्रहों को उनकी निर्धारित कक्षा में स्थापित कर दिया है.
And now comes something very, very interesting. You can see on your screen from on board the cosmic bloom and the micro art. And we have sun rising behind it. It is the dawn of a new space era.
ये एक नए अंतरिक्ष युग का प्रारंभ है. सूर्य के किरण ने ये प्रकाशित कर दिया है.
Skyroot has actually completely redefined orbital flights, I guess, forever.
यस, अवश्य. ये कथन बिल्कुल
17 minutes.
So right now we are awaiting
Hello
the
everybody.
Cosmoser
Today we have created
satellite
history.
to
VIKRAM-1 mission is a grand success.
and we've heard call out from the mission director that the Agaman mission is a grand success.
सफलतापूर्वक प्रथम मिशन आगमन ने इतिहास के पन्नों में अपना नाम अंकित कर दिया है.
Hello space, we have arrived. Thank you for joining us today.
Thank you for being with us on this historic journey today. With Raman 2 and VIKRAM-1 now safely in orbit, we are not just reaching space, we are opening space for all.
आज की इस ऐतिहासिक उड़ान में हमारे साथ जुड़ने के लिए आपका हार्दिक धन्यवाद. विक्रम-1 ने सफलतापूर्वक सारे उपग्रहों को कक्षा में पहुंचा दिया है और भारत के अंतरिक्ष सफर में एक नया उज्जवल अध्याय खोल दिया है. धन्यवाद. जय हिंद, जय भारत. गुड आफ्टरनून. Good afternoon, everyone. We'll let them celebrate. Good afternoon. I am privileged to formally announce that the first ever Indian private sector launch has been successfully completed. Not only did Vikram-1 meet its mission objective, which was simply to clear the tower, it went all the way up to 453-kilometer orbit, successfully completed all the tasks, and something that is way beyond expectation for the very first orbital launch ever taken. There is not much more that I want to say on this occasion. I would like to invite Pavan and Bharat to talk about their journey and how they feel today, this momentous milestone that Indian private sector space initiatives have had. And I would like to thank everyone involved in this. Of course, the Skyroot team. The Skyroot team has worked day and night to make this happen. Heavily supported by the team from SAR, from ISRO, and from InSpace. So thank you everyone for giving India this proud moment. Thank you.
Hello, we have Pawan and Bharat from Cairo. Sir, we are very privileged to hear you. First, your voice after the success.
और दूसरा उस रूप को आपने मजबूती दी, देश के नौजवानों को आगे आने की प्रेरणा दी और मुझे ये सफलता की आनंद होना ही होना था कि आप लोगों ने कमिटमेंट के साथ मेहनत की। और मैं जब आपके आपके साथ जुड़ा था, मेरे को मन करता था मैं पहुंच नहीं पाया, लेकिन आपके साथ जुड़ा था। और आज भी मैं इस पूरे लॉन्चिंग कार्यक्रम को देख रहा था। कब से मेरा ध्यान जो गया आपकी 25 साल की जो और खुशी दे रही थी। शुरू में आपके चेहरे पर चिंता नजर आती थी, खुशियों से माहौल भर गया। मैं आपको आपकी पीढ़ी को महत्वपूर्ण निर्णय के लिए और महत्वपूर्ण सफलता के लिए मैं बहुत बहुत बधाई देता हूँ। तब मेरे सामने कई सारी आशंकाएं रखी, ये तो हो नहीं सकता, कैसे करोगे वैसे ही करोगे, लेकिन मैं इनको आगे बढ़ता ही गया। अब आपके कारण अब मेरी टीम भी स्वीकार करेगी, यहाँ देश के नौजवानों को भरोसा करना चाहिए, उनको काम देना चाहिए और वो करके दिखाते हैं। आपने काम करके दिखाया है। बहुत बहुत बधाई देता हूँ।
Hello, sir. Thanks a lot for your wishes. And our team, entire team of Skyroot, more than 1,000 people are here in Sriharikota and listening to you. Our hearts are swelling with pride, and this means a lot to us. Sure, sir. और सर आपका कार्ड जो आप भेजे थे, that has successfully reached space and you have written Vande Mataram. So Vande Mataram is in orbit.
बहुत खुशी की बात है। जब आपने सुझाव भेजा तो मेरे मन में कई विचार आ गए थे, लेकिन आगे जब मैंने सोचा मैं सिर्फ वंदे मातरम लिखूंगा। उसके दो कारण थे। हमारा देश वंदे मातरम के 150 वर्ष मना रहा, तो मैं चाहता था कि इसको एक नए तरीके से मनाए। और वंदे मातरम ही था जिसके नौजवानों को हमेशा बनने की प्रेरणा देती। और आज वंदे मातरम हमें ताकत देता है। और आप लोगों ने जीवन दिखाया है। आपका जो मिशन है, मैं इसको एक प्रकार से वंदे मातरम मिशन ही लिखता हूँ। भारत माँ की गरिमा को नई ऊंचाई पर पहुंचाना, नई पीढ़ी को टेक्नोलॉजी को लाभ देना और नई पीढ़ी को टेक्नोलॉजी में आने के लिए प्रेरित करना, इस हर प्रकार से। और उसमें से मेरे मन में विचार आया कि मैं कुछ ना लिखूं, सिर्फ वंदे मातरम मेरे भाव व्यक्त करूं। और मुझे खुशी है कि कल आपने उस बात को मीडिया से भी शेयर किया और आज इस सफलता के साथ वंदे मातरम का भाव भी नई ऊंचाइयों को पार कर रहा है।
Thank you, sir.
मैं आपकी पूरी टीम को बहुत बहुत बधाई देता हूँ और जल्द से जल्द आपको मिलने के लिए निमंत्रण भी देता हूँ।
Thank you, sir. Thanks a lot. Thank you, sir. We are privileged to hear you. Privileged to have your blessings. Entire team of Skyroot, entire India is really proud of your initiative to start the space program, open it up to private sector, and now we see historically, first time probably a private company have built and successfully reached an orbit in the first attempt. Thanks a lot. It's happening from India, and this is a 100% designed in India rocket, 100% manufactured in India, and I think thanks to entire team Skyroot, whose average age is just 28 years.
आत्मनिर्भर भारत की बात करता था तो ना कभी में अपने लोगों की मजाक उड़ाते थे, लेकिन आज आपने सिद्ध कर दिया कि हम इस क्षेत्र में भी आत्मनिर्भर बनने में समर्थ हैं और आपने उस समर्थन को दिखाया है और मैं पक्का मानता हूँ कि अब सबूत हमारे सामने है, साक्ष्य हमारे सामने है और ये आपकी टीम ने करके दिखाया है।
Thank you, sir. Thank you.
खुशियां मनाने में लगे रहेगी।
जरूर सर, एंड in fact हम जब 2018 में स्काईरूट स्टार्ट किया था, उस टाइम पॉलिसी नहीं थे, देयर वाज नो फंडिंग एनवायरनमेंट और प्राइवेट सेक्टर में टैलेंट भी नहीं था, और हम फिर से हमारा जॉब्स छोड़ के स्काईरूट चालू किया था, एंड नाउ वी आर वेरी प्राउड दैट the government is enabled us and opened up the sector to private players, and now we stand as India's first private company which have launched a rocket to orbit and also created a global milestone, all from India with a fully Indian team, 100% built in India. Thanks a lot for enabling this journey and also setting a vision, big vision for 50 launches in 2030. Definitely, I don't see it as a challenge, sir. Thanks a lot for your encouragement, and looking forward to meet you, sir, in person. Thank you. Garur, sir. Thank you. Thanks a lot, sir.
सबसे पहले मेरा आपको सचमुच में मुझे देखकर तो खुशी हुई थी, इससे मेरे देश के नौजवान खुशी की बात है। बहुत बहुत बधाई और बहुत बहुत शुभकामनाएं। आपने जो टारगेट तय किया है वो समय से पहले टारगेट पूरा होगा, मुझे पक्का विश्वास है।
थैंक यू सर, थैंक्स अ लॉट। हम जरूर कोशिश करेंगे। थैंक यू सर, थैंक यू। Absolutely no words. Absolutely no words. Go! Go! It's so heartening to hear the Honorable Prime Minister talk so highly about Skyroot, so highly about India's youth. I think this is a historic moment, not just for Skyroot, for India, and also entire global space sector. In the first attempt reaching orbit, I never thought it was possible, and Skyroot team made it possible. Big shout out to this phenomenal team which made it happen. And in fact, this launch was nothing short of a suspense movie. We all experience the highs, and never have we seen such suspense. And I think it's all worth it at the end. And I think really happy today, and that we have achieved something very rare, very unique. It shows the potential of India's talent. And today, in fact, we stand here at one of the best spaceports in the world, and we are very proud to launch Vikram-1, one of the most versatile launch pads in the world, and really thank ISRO for enabling this. And more importantly, I would like to appreciate and also thank entire InSpace team, which has efficiently authorized this launch. And in fact, I've seen countries, companies waiting for launch authorization for so much time, and India has proved it that government is the most efficient. And in fact, they enabled this launch in record time. There was zero delay in authorizing India's first private orbital launch. And like I was telling the Honorable Prime Minister with pride, this is a 100% designed in India rocket, 100% made in India rocket, built by 100% Indian people for India, for the world. So in fact, I've written a speech, but I'm just out of words. And I'm so happy today. And really, this journey is only possible because first, Team Skyroot, of course, the government, the Honorable Prime Minister for his vision to open up the sector to private players. And then now today, India is proud to be the fastest growing space tech ecosystem in the world. And now we achieve one of the biggest milestones ever in India's space sector. First private orbital rocket reaching orbit in the very first attempt. It still feels like a dream, and you all made this dream happen. I have no more words, and really appreciate everybody making this happen. In fact, we can see, I think all the hearts were racing up. It was not Skyroot, it was not InSpace, it was not ISRO, it was not the people watching, the public watching in the gallery, people watching online. Everybody's heart was beating for India. Everybody's heart was beating for Mission Agaman. And we made it happen. It's one nation, one mission for the world. Thank you.
So I request all the Skyroot folks here just come up on the stage. Don't leave any inch remaining on the stage. Please occupy the stage now. So as mentioned, simply we wanted to prepare something, but there's simply no words. I just wanted to send the deep sense of gratitude to InSpace for being the enabling pillar, the key pillar in enabling each of our milestones so far, and a big thank you to ISRO and all its center, VSSC, and especially SDSC and Distract, who have extensively supported us throughout the launch campaign with extended hours. And it's one of the best support we've received, and our team felt like a home away from home, and they truly owned up Vikram-1 as their own throughout our launch campaign. A big thanks to ISRO and all its centers for that. And I can't express enough gratitude to our early investors and all our investors who have been our backbone, who gave us the muzzle to execute with the pace we did so far and achieve the milestones in a timely manner. Thank you so much for believing in us on a vision way early before we could achieve, before it can turn into a reality. And lastly, just about the Skyroot team, a big congratulations to all of you. You achieved something remarkable. But in addition, we owe a huge debt to your families who supported you throughout your journey in Skyroot and who stood by you, which made your journey possible in Skyroot. And all the and their quiet sacrifice stands behind the gift to the nation we have given today. Thank you so much. Thank you.
Oh, thank you, Pawan and Bharat, and that was so exciting, and I can see the excitement in everyone. And I want to tell the team that these are moments in life that only comes once in a while. Savor these moments, and this will live with you. You're all 27, 28-year-old. Will live with you till you become my age, and maybe even longer. So I would now like to request Minister of State, Dr. Jitendra Singh, who is waiting there from his office. He wanted to come here today, but could not because of other engagements. So I request him to encourage the team and appreciate the work that has happened here today. So, Dr. Singh, Honorable Minister, sir.
So congratulations, Skyroot, for becoming India's first private player to have executed a launch from Sriharikota. And congratulations in space for facilitating this beautiful public-private partnership. Congratulations, ISRO, for optimizing this collaboration. And congratulations and thanks once again, Prime Minister Narendra Modi ji, for making this possible by opening up, by unlocking India's space sector and allowing private players like Skyroot within the four walls of Sriharikota. If Prime Minister had not announced the space reforms and allowed opening of the space sector to the private players, we would have been deprived of witnessing this lifetime event, because this launch would not have happened, and Skyroot would not have been able to show us or to showcase the enormous talent at their command. Ladies and gentlemen, I have had the opportunity of watching Pawan and Bharat right from the beginning, have been closely following their journey, and I must say the distinct feature of this team is that besides being technologically competent, besides being talented, they are always extremely innovative, extremely creative, which is evident even from this launch. The VIKRAM-1 payload of 350 kg is not an empty payload, as many of the maiden flights usually carry a dummy load or a dummy mass. Here we have an experimental payload or experimental mass. And what a miraculous quantum leap it has been over the last 5 years since Prime Minister Modi opened up the sector. From a modest space economy, today we are close to $9 billion and hope to go up almost 45 billion in less than a decade. From a single-digit space startup, today we are more than 400 space startups and one unicorn, Skyroot. Skyroot, the star of the day. And today's successful launch is a reiteration of India's entry as a global player in the highly competitive arena of space economy. And now, ladies and gentlemen, for India, sky is no longer the limit. May India rise higher and higher. Congratulations once again.
एक मिनट थोड़ा साइड हो जाइएगा
सर सर टेबल खोलेंगे सर इंटरेक्शन के लिए टेबल बंद कर देना
सर सिंगल सबको देंगे मैडम शुरू कर आराम से वरना सिंगल नहीं करनी
हाँ बेटर है स्टेज पे लगा रहे हैं पीछे से लगा स्टेज पे प्लीज मैम आगे बना स्टेज पे ले आप नीचे से पूछो स्टेज पे दीपक दीपक म्यूजिक लगा टेबल पे भैया आप नीचे आओ सर ऊपर आ रहे हैं नीचे आओ टेबल रखो यार पैर टेबल चेयर रखो ऊपर
Congratulations, Skyroot, for becoming India's first private player to have executed this launch from Sriharikota. Congratulations InSpace for facilitating this beautiful public-private partnership. Congratulations ISRO for optimizing this collaboration. And most of all, above all, congratulations and thanks, many thanks, Prime Minister Narendra Modi ji, for making this possible. Because it is possible only because 5 years back, Prime Minister Modi took a heroic decision, a bold decision, a courageous decision, an out-of-box decision to open the space sector to the private players, to unlock the space sector. And had he not done that, we would not have been witnessing this event today, because this launch wouldn't have happened and the sky route wouldn't have been there. And what a remarkable, a revolutionary quantum leap it has been over the last 5 or 6 years, ever since the new space reforms were brought in by Prime Minister Modi. From just a modest economy, we are today more than $9 billion US space economy, hoping to be 45 billion in less than a decade. From just one digit or a single digit space startup, we are over 400 space startups and a unicorn in the form of Skyroot, the hero of the day. And I can say with all the confidence in my command that today's successful launch is a reiteration of India's grand entry as a global player in the highly competitive arena of space economy. And now for India, sky is no longer the limit.
Sir, when 2014, one startup in space sector, now almost 400. How the journey has been?
Yes, it's been miraculous over the last just half a decade. Half a decade is hardly a time in the life of a space sector. If you compare us with those who started much earlier than us, for example, the then Soviet Union, the USA, and not only that, our record of first-time success has also been is remarkably higher compared to the other nations. Even today's one is added to that record.
Right. So do you believe, sir, more such startup will be given more opportunities?
Of course. Now, for example, the VIKRAM-1 is just is a test flight by this accomplished group of Skyroot, and then they will be also commercializing it and going in for further. Similarly, I think a healthy public-private synergy in the space sector is what is going to make it more and more competitive. So we will have to find ways and means of optimum synergy and integration between the government and the non-government sector space players.
Right, sir. That's what Union Minister, that was Union Minister.